Gentlemen, welcome back to the shop. Today we're talking about rendering in the GPU and encoding in the GPU. Cinelerra has always supported some kind of hardware playback using either the GPU or a dedicated codec. But by 2022, 4K Vijaya resolutions and newer codecs like H.265 were making the rendering process quite slow compared to playback. And if you had an expensive GPU, you didn't want to just use it for playback, you wanted to use it for rendering. Video encoding in the GPU is probably the biggest requirement, so that's what we're going to cover first. The way files are written using the GPU is by writing to a system copy of FFmpeg. A version of FFmpeg which supports hardware encoding is not officially included in the Cinelerra distribution because of licensing restrictions. Although, there may or may not be an unofficial copy of FFmpeg which does support hardware encoding. The way you'd find this out is by running FFmpeg with the dash codecs option and then send that to a debug file. And then if we look at all our codecs in a text editor, you want to look for the NVEnc codec, which this one has for H.264 and H.265. Once again, this is an NVIDIA only feature. It officially has to be compiled from scratch and installed in your path. There is a buried document showing how to build FFmpeg with hardware support. You go to it by putting FFmpeg with NVIDIA GPU in the doobly-doo, and one of the top results should take you there. The trick with this is that you have to have a working CUDA installation. As far as configuring Cinelerra to use the GPU for encoding, there have always been various forks which could do it one way or the other, and finally there is a brain-dead way of doing it. Let's load some test footage. Go to File, Load, select some random file in a very high resolution, select Replace Current Project, select Conform Project. To use the GPU for rendering, go to File, Render, enter an output file name. For the file format, select Command Line. This format is intended to outsource all the encoding and the wrapping to a command line program. It can process just audio, just video, or both. The render audio tracks and the render video tracks create elementary streams. And as the final step, the wrapper option combines the elementary streams into a format which can play back. The main thing we're interested in doing in the GPU is rendering video, so enable render video tracks. Then go to the wrench icon, and you'll find the configuration. This has a number of presets. Highlight a preset, and click on Load to make this the current encoding command. FFmpeg CBR is a constant bitrate encoder for H.265. VBR is a variable bitrate encoder for H.265. In the command line, when I load each preset, you'll see either a -QP option for a quantization factor or a -B option for a bitrate. There's also a preset for H.264. On my GPU, the H.264 encoder is much slower than the H.265 encoder. It might be that the H.264 encoder was done a lot earlier than the H.265 encoder, and it doesn't use as many techniques as were available when H.265 was introduced. So if you're a poor lion with a very lousy, inexpensive GPU, you're going to be better off encoding H.264 in software. And finally in our presets is the ever-important null encoder. This just throws away the output. This is useful for benchmarking. But let's reload the HEVC VBR codec. You can make changes to the command line. You can change the preset title. And then after making changes, you want to hit save. It'll ask you to overwrite the preset. If you change the preset title, it'll just create a new preset with the new title, which I'm going to delete now. If you make a change to a preset and then later decide you want to revert the preset to whatever came from the downloaded binary, just delete the preset, restart the program, and it'll recreate the preset with the original settings. In the command line, you'll find various formatting codes, %R, %W, %H, %1, and how these are used is described in the window. It's going to replace the formatting codes with different parameters that you need to configure FFmpeg. And finally, there's the color model. Cinelerra will try to convert the rendered output to this color model before sending it to FFmpeg. Most of the time you just want to use YUV420 planar. For the audio, we have a similar window. The audio uses FFmpeg as an encoder. Our formatting codes have changed to reflect audio parameters. And then the output is going to be a sample format, which is almost always going to be floating point. And then you have other parameters for audio output. Let's demonstrate a common problem when encoding audio using the command line. So I select FFmpeg AAC, which is an AAC encoder. But say I select the wrong sample format to write to FFmpeg. Now when I try to render it, it fails. And it gives input contains near NAN plus minus inf, which is about the most useless error message ever. But what this usually means, if we go back to our render screen, is that the sample format being written to FFmpeg is wrong. It's expecting floating point because it has F32LE. If you give it 16-bit integers, it's going to interpret that as invalid floating point numbers, and it's going to give you an error about not a number and infinite. So suppose I render a short video, maybe 30 seconds, with audio and video. The next thing it's going to do after creating the elementary streams is create the wrapper, if I select Create Wrapper. So let's see what this does. This takes a similar command line. We use FFmpeg to multiplex the elementary streams. We have one preset which takes an audio stream and a video stream and sends them to an output file. We have another preset which just reads a video stream and creates just a video file. And then we have a preset here that just reads an audio stream and creates an audio file. You normally need to create a wrapper even if you only have one elementary stream, because most players can't play elementary streams, they can only play the wrappers. A very important option in the wrapper settings is deleting the temporary files. This is going to delete the elementary streams after the multiplexing is finished. But if you're still setting up a wrapper, you're not quite sure of the command line options, and the wrapper doesn't work, you may not want to encode the elementary streams over and over again to try different options. In this case, you would deselect delete temporary files, and you would want to run the wrapper command on the command line outside of Cinelerra to test it out. Another common problem, which you'll find here, is the famous CUDA error unknown. This happens, at least on my version of the NVIDIA drivers, after going into hibernate mode. You just have to unload the module before rendering, and then try rendering again. That forces it to reload the module and reinitialize the GPU settings. This took 25 seconds. One problem though is it's so fast that if you have the compositor window open while you're rendering, you can actually slow it down. This particular GPU and monitor max out at 60 frames per second 4K, and the GPU can't output any faster than that because of the HDMI synchronization. So what you want to do is close the compositor window when you're rendering, and that way it doesn't have to draw the video through HDMI and get slowed down by the HDMI synchronization. And here you can see it's screaming along, and we did it in 18 seconds. So what happens after you've got encoding and hardware working? Well, you don't want to be doing all that rendering in software if you're encoding the file in the GPU. You want to use the GPU for rendering. To use the GPU for rendering, we go to Settings, Preferences, Performance, and select the Use OpenGL for Rendering option. All the software that was written after 2006 to use the GPU for playback is now used for rendering. This mode is still not supported for background rendering or render farm mode. Background rendering and render farm mode haven't really been tested in years. They're not really all that important with modern hardware, so they might not work anyway. If you have Use OpenGL for rendering, and you're using the command line encoder using a hardware-enabled FFmpeg, and your compositor window is closed, it's going to render it as fast as possible. One problem that comes up with GPU rendering more often than CPU rendering is the limited RAM in the GPU. There are some projects which are going to take too much memory to have the timeline open while they're rendering, because all the memory that's used for displaying a preview in the compositor is going to stay there while it's also using additional memory to create the rendering output. In this case, there's an option. What you can do is, first of all, save the timeline with the region that you want to render selected. And we're going to save this as test XML. And then we go to File, Batch Render. This mode was originally intended to process multiple rendering jobs in succession, but it's also the only rendering mode which works on the command line. So let's just delete all these. Let's start by creating a new rendering job. First step is to configure the output path. I'm going to use the same file that we used before, test.mp4. The EDL file is the file we just saved, and the file that's currently on the timeline. So you can just say use current EDL. And then for the file format, we want to go as fast as possible, so we're going to use command line mode. FFmpeg AAC floating point as defined by the preset. And then we select variable bitrate, H.265. And then we select the wrapper to multiplex audio and video. And delete the temporary files. Most importantly, make sure the enable column is selected so this rendering job runs. And then we close the batch rendering window and we quit the program. And now to render from the command line, we do Cinelerra-R. It's going to prompt to overwrite the output file. So we hit a Y followed by enter. And there it goes. It's now using the GPU for all the rendering and all the encoding. It's going at about 1.5 times real time. And it's using a lot less memory than it would if you had the timeline open. A common mistake is configuring the rendering to use a command line and then assuming it's going to use the GPU for rendering, even though use OpenGL for rendering is disabled. These two options are not the same. If use OpenGL for rendering is disabled and the output is going to the command line, it's going to use the CPU for the rendering and the GPU for the encoding, and it's going to be really slow. And this concludes rendering and file encoding using the GPU.